am passionate about ESP projects. I started with ESP-8266 module, also known as NodeMCU. While searching for NodeMCU projects, I came across Deother, a brilliant project. However, the ESP-8266 support only single-band Wi-Fi, which it limited its potential as a standalone prototype. But now Espressif is ready with the new ESP32C5, a dual-band device. Today let's explore Deother with this new chip. The Deother repo is known as GHOSTESP. When I Google it, the link appears at the top. We can find the latest repository link from this website. When I open the link, it redirects to GitHub. We can download and customize the code if we want. The developers used ESP-IDF to build this project. At the end of this video, I will show you how to configure the project in ESP-IDF. In the README of GitHub repository, they have included a link to a flash tool which is also developed by them. Flasher.ghostesp.net. Using this website, you can complete the entire firmware flashing process in just 4 easy steps. Step 1. Select your ESP32 variant. In my case, it is ESP32C5. Then continue. Step 2. Connection settings. First thing is baud rate. Keep it as 115200 and the reset method normal. Manually put the ESP into boot mode. Long press the boot, press reset, release. Click on the connect to select the port number. It detects and identifies the board ESP32C5. Click continue to advance to step number 3. Download latest firmware. We are using GHOSTESP project and ESP32C5 version. Before flashing, make sure the flash size is selected appropriately. Show more option. I am having 8 MB ESP32. So you can see here it is N8R4. Select 8 MB. Continue. Flash firmware. First it will erase. Erasing is done. And it is trying to upload. So while uploading, let's see the output log itself. If there are any errors, we can find it here. After flashing, we have to do a manual reset. Before performing a manual reset, let's explore their serial tool. Go to GHOSTESP, the main website. There you can see serial console. Connect. Select the combo, that is 23. It is connected. It's time for hardware reset. The ESP is ready. The repository is capable of performing memory card related operations as well. However, since no memory card is connected at the moment, that's why this warning being shown. It's time to see how to use it. The commands are structured like familiar network commands. For example, in Windows we use ipconfig to get the IP address. Similarly, these commands are created in that style. In the next step, we will select the target device. I am going to test the Deother on my own device. When you are testing Deother, always ensure you are targeting a network that you own or have proper permission to use it. I am using Xiaomi 6 as the Wi-Fi device. I have turned on the hotspot and the network name is Xiaomi. I have selected the access point bandwidth as 2.4 GHz. Now it is time to check the first command, access point scanning. So the LED is turned on. We have to wait for 10 seconds to get the nearby Wi-Fi's. So here you can see it found all 2.4 as well as 5 GHz Wi-Fi's. Mine is Xiaomi and the current bandwidth 2.4 GHz. Let's check the compatibility of 5 GHz bandwidth in ESP32C5 so that I will change my hotspot bandwidth as 5 GHz. Save the settings. Let's scan it again. So before scanning, let's clear the console for a better visibility. Again, wait for 10 seconds. All the Wi-Fi will be listed. So these are the Wi-Fi listed and this is the device. Now it is changed to 5 GHz. To show you the attack, I will connect my laptop to the Xiaomi hotspot. So here Xiaomi is connected. To attack, we have to use attack-D. So before attacking, we have to select the Wi-Fi. For selecting, we will be using this command select-A then the number. The number which I got here is 4. Give the command select-A 4 then hit enter. So let's verify. So we are attacking the Xiaomi. Now let's attack. Attack-D hit enter. Red LED is turned on. So it started to send the packets. So in the screen you can see the connection is getting connected and disconnected, connected, disconnected. It is blinking like that. Let's check the internet connectivity with the Google. You can see it is still trying to access to the google.com, but it is not able to connect because of the deother packets that we are sending from ESP32. Now let's stop attacking. To stop attacking, stop deauth. Let's copy paste it, hit enter. So it stopped. Now let's refresh the web page. That's it. That's how we are uploading the firmware for GHOSTESP through their website tools. Now let's see the same thing with our ESP-IDF. Since GHOSTESP is an open source repository, I am going to build and flash locally from my laptop. First we have to download the zip file, then extract and open it in the VS Code. From this config folder, we need to take the default configuration. Now I am going to use for ESP32C5. Okay, it is moved to here. Next I have to select the device. It is C5. SDK config.default is not available, so I have already copied this one and it is with the default.esp32c5. Let's rename it to SDK config.defaults. Again, let's select the device. Build and deleted. So C5 is set without any errors. Next we have to select the comport. Menu configuration. So menu configuration is done. Let's save it. Okay, all done. So in this monitoring means we can only monitor. I need a separate serial monitor. Already have an extension for serial monitor. Combo date is 23. Start monitoring. First step, as usual, reset the board. Done. GHOSTESP is ready. Scan it again. Scan API. LED is turned on. Scanned results are available. This is how we will be uploading it from the computer. In this session, we have successfully configured the ESP, tested the deauthor functionality, and followed all ethical practices. Make sure you use such tools only on authorized networks. Thanks for watching and stay tuned for more advanced tutorials.